Good. Everyone back? But I can't ask that here. The questions are all the way around. No? Okay. Fine. So, we're going to carry on with the last talk of the evening. Jamie's come up with a plan for the Arnold Schwarzenegger message, which we're going to be doing with multiple cameras later. We're going to do it straight after this talk. What that means is, when Michael's finished, we're not allowed out until we've done the message. If it takes 100 takes, it takes 100 takes. Okay, I'm going to shut up now. Michael's been giving an introduction to DCOS, which is hopefully going to be more in-depth than the one we've given previously, otherwise that's going to be a bit of a clusterfuck. Big round of applause for Michael Hutzenblatt.
No pressure, right? All right, thank you very much. All right, it's a bit late. I hope you grabbed a beer and are still with me. Trying to keep it as short as possible to have some time for questions, and a very short video in there as well. So, my name is Michael. I'm taking care of DevOps relations at Mesosphere. My background is in NoSQL Hadoop world, worked at MapR, the Hadoop distribution, and I'm also contributing to a number of open source, Apache open source projects. Now you know a bit about me, and I'd like to know a bit about you. Kind of show of hands, who is familiar using or whatever Docker? Okay. Mesos? Cool. And the DCOS? Oh, wow. More people using DCOS than Mesos. Okay, we got to clarify a few things here. Let's have a look at a few challenges and trends first. Gonna go through that, and feel free to interrupt me at any point in time. We don't have to do the Q&A at the end. Pick things like that I think we're currently going through, and basically also moving on where Jamie started, and I really appreciate that talk. That to me it was really very inspiring, the initial talk by Jamie. This time to market, right? Business comes around, says, "Hey, we need that new feature." No matter if you're in a multinational company, HR or marketing, whatever, says, "Hey, we need that new app or new feature tomorrow." Or if you're in a startup, number one customer comes and says, "Hey, we need that new business feature tomorrow." We live in this always-on society. We really want to do everything at any point in time, at any point in space. And if you can't out-innovate your competition, then you're pretty much out, and that's where it ties in with what Jamie said in the Valley of Death. One of my pet peeves, and I really think we have to thank the DevOps movement here overall, is that immutable infrastructure. Who of you has not heard about immutable infrastructure yet? Everyone knows what that is. Okay, I can keep that short. I don't want to see that slide anymore, right? That's not fair. That's not cool. One implication, though, this automate everything, we heard it already a bit today, is if you cannot commit to that, to really automate everything, the entire CI/CD pipeline, you might have a problem with having totally subscribing to that pets versus kettle, and being able to have really immutable infrastructures. Docker is a really cool first step. You will have these Docker images, immutable pieces there, but you really need the entire pipeline, so you need to be able to automate everything. And yeah, at the end of the day, at some point in time, there will be costs. For a lot of startups, public clouds are more or less the default, but more and more, brick and mortar established companies also look at that in all seriousness. And maybe in Europe we have a bit more challenging times in terms of regulations and so on, data protection. But more and more people I see are actually using public cloud more and more. At some point in time, you also, if you're running cluster of machines, you want to think about your overall utilization. And as we've already seen today, DCOS actually can help you with that. And then there's that thing in terms of open source. Open source is good. You can look at that. You can fix your own shit. But you might not have that mentality. You might be either buy or build. At the end of the day, you want to have a taught, right? Not everyone wants to be a taught, but you want to have a taught to reach out and someone helps you there. Now, one question I ask myself is, looking at the operating system scene at all, and they're especially distributed operating systems, is that an evolution or a revolution? Let's take the example of a single box app. So I'm developing a Mac OS application or for Android or whatever. So I have a piece of hardware there, I have the operating system, and I'm mainly concerned about that here. I depend on and assume that there are certain common services the operating system gives me. I don't care about where to launch tasks, how to manage the memory, user management, file system, whatnot. I'm programming against a certain API. I have an SDK there, and there is a good reason why this operating system is there. There was some insight over the years why that makes sense, why not every application duplicates a lot of code to talk to the hardware and do things. Now, next, let's have a look at the typical distributed application. You still have this hardware. Here we have a 7-node cluster and a now local operating system because it's operating local to that hardware, and we call that a node, and you have that application. Now, in the application, you will have to deal with two things. On the one hand, with the business logic, the thing that you're actually making money off of, and the other part is doing all that communication between these different nodes. You have to take care of, in your application code, what happens if one task of my application fails. How do I keep track of that? How do I launch it somewhere else? And so on and so forth. So ideally, in an ideal world, you would have that. You would have the node with its local operating system and a distributed operating system that would oppose or would make the whole cluster of machines look like one single machine to your application, and you're back where you were in the single case. You don't need to take care of all this networking code, failover or whatever. You just write your business code up there. Make sense? This is really crucial. This is the starting point. If you get that slide, the difference between this and that, your code base gets smaller, fewer bugs, you get faster time to market. And also, if you look at that, the local operating system code, essentially the code base, the image size gets smaller. That's why you have things like CoreOS or Intel Clear Linux or whatever. These are stripped down, optimized for this cluster operation and assuming this distributed environment. Okay? So far, that was kind of theory. Now, there is something out there, what we call the data center operating system. And if you look at that, why didn't we just call it the data center operating system, DOS, because it might trigger the wrong associations. That's why it's called DCOS, right? There you go, marketing spin. So you start with some kind of environment. It might be virtualized on-prem, it might be in the cloud, whatever you have. You typically would have, as I said, some kind of provisioning tools there to set up your nodes. You would then have Mesos as the kernel of this distributed operating system. You would have a number of kind of low-level system services that allow you to orchestrate, manage, typically containers, but also existing things like jar files or whatever you want to run. And then essentially you would have your distributed applications there. Right? And that is actually the way that we currently see this first wave of people and organizations who adopt Mesos build their system. That's what I didn't make that up. I essentially looked through how systems are built there and what was reported so far, and that is the typical system. Some prefer the one over the other, but that's what you essentially have. And these are the people who are doing that. And some of the logos you might recognize. I just pulled some of the powered by from the Apache Mesos site itself. And they use it for different cases. But all of them have in common that they realized it makes a lot of sense to have a distributed operating system that takes away many of the things that you would otherwise have to do in the application code itself. Right? So the DCOS itself comes in two editions, as we call them. If you're cloud native and you're only running in the cloud, that's the community edition, so you get it for free. There are no limitations in there. It's literally a single-click install. So you essentially go there, click on it, takes average 12, 15 minutes, whatever, however fast the underlying provisioning system is, and then you're good to go. Then you essentially are there. What Phil earlier showed you, the DCOS UI, and you can start, launching applications. Just one thing. When I heard that earlier on, I got the impression that people might be scared off a bit, like, oh, if I want to use Mesos or DCOS, I have to go through all of what those guys have been gone through. That's not true. It's those guys who invest a lot of time writing these wonderful frameworks, and you benefit from that. I mean, how many people who wrote Windows applications 10 years ago wrote a Windows device driver? Probably not that many, right? So you probably, in 99% of the time, will use existing frameworks or services, as we call them now, and just launch your stuff. You will depend on people like Phil and Frank that go through all that pain to create these frameworks. There's community support there. As I said, no limitations, currently available on AWS and Google Cloud Platform, and Azure coming very soon. And that's what you essentially have. You have Mesos, as I said, as the kernel of the distributed operating system. You've got these services around there, and the UI and command line interface. If you need to or want to run the DCOS on-premise, then the Enterprise Edition, and because we obviously need to make some money somewhere, that is actually where we get the money from, right? So there's on an annual subscription basis per node, and you can do hybrid cloud deployments. This is really what you want if you are on-premise. You get things like security, support, and so on included, emergency patches. So this is really, if you have these requirements, you want to have it on-prem or in any other cloud that is currently not in the community edition, then you want to have a look at the Enterprise Edition. All right, so what do you get if you look at the DCOS? We saw that already a bit in action. On the one hand, you have the UI that gives you a bit of an idea of the overall cluster utilization, what services and nodes are there. You have a command line interface, which you can use for scripting and integrate that in your current workflow. You've got a couple of services that you can, each of them essentially install with a single command line command, essentially saying, yeah, DCOS install package, Spark or Cassandra, whatever. Depends on some of them, like Spark typically needs HDFS beforehand. In average, maybe between 5 and 10 minutes until everything is configured, all the nodes are set up, and you can actually start using it and using it in your applications. And as I said, again, quite central, Marathon. So that is essentially the way how you either through the web UI we've seen or through a command line interface using the REST API Marathon exposes, essentially launch long-running tasks, so tasks that you or applications that you expect to be always up, and Marathon takes care of restarting them if a node fails or whatever happens. And last but not least, as you would expect, these core system services, on the one hand Mesos, doing all the scheduling and so on. You got the exhibitor UI for the Zookeeper and Mesos DNS. If you remember earlier on, you saw that in the config, there was master.mesos. So that's what Mesos DNS essentially provides you. It does this DNS resolution within the Mesos or DCOS cluster, translating these internal logical names, whatever, like if you have it under Marathon, you have an application that's called demo, it would be called demo.marathon.mesos into IP port pairs, which is a very nice way to do service discovery. You can use these logical names and you're not dependent on IP addresses. Okay, now I think I need to give you a signal that you switch something there so that we can hear the audio. I think the audio comes from mine, but you need to switch something for the recording whenever you're ready.
Hi, this is Matt Trefiro with Mesosphere, and I'm here to demonstrate the new Mesosphere Data Center Operating System, the DCOS. The DCOS is a new kind of operating system that spans all of the machines in your data center or cloud. It lets you intelligently manage and orchestrate hundreds, thousands, or tens of thousands of servers anywhere. Here we can see our data center dashboard. Each circle on our dashboard represents a node. which can be either a physical or virtual machine in my private data center or an instance in a public cloud. Here I have 6 nodes, and they aren't running anything, so the CPU indicator is at 0%. Operating systems come with many different components, and ours comes with a command line interface, which you can see at the bottom of the screen. We're going to use the command line to launch an application using a tool called Marathon, which is a way to deploy and scale any application, Ruby on Rails, Python, Java, with no code changes or environmental setup. For example, to launch a Rails application, we type DCOS, Marathon, app, add, and then a JSON file with the Rails application. The Rails app is automatically placed in my data center. You can see it starting up in one node. Notice that I didn't have to specify which node I wanted it to start on. Now, it's pretty straightforward managing a data center that only has 6 nodes. But what if I had 100 nodes? Let's resize our cluster by typing DCOS cluster resize 100. The cluster resize command connects to your cloud provider or your on-premises provisioning system and adds DCOS instances to your data center. Watch how the new nodes are automatically provisioned and connected and available for running applications. There's no complicated setup or configuration involved. Now that we have all of this extra capacity, let's scale our Rails app to 10 instances. That's easy too. You simply type DCOS Marathon app update, the name of the Rails app, and the number of instances you want to scale it to. The Mesosphere DCOS immediately responds and starts to add 10 instances to our Rails application and connect them to the load balancer to serve more traffic. Modern enterprises will require more than a Rails app to run their business. For example, you almost always need a database. Let's install Cassandra, a high-performance distributed database from our library. Now that we have a database, we can also add a file system like HDFS. HDFS is a highly distributed file system that can run across dozens or thousands of nodes and can be used for storing logs and data from applications. Here I am installing HDFS. HDFS is automatically installed as a service in my data center, and it's available for anybody to use. But we don't just want to store data, we need to analyze it. So let's install Spark, a big data analytics and data processing tool that came out of UC Berkeley. It's a very fast, in-memory data processing system. Now let's go back to the node view and see how our data center has changed. Spark, HDFS, and Cassandra are now listed as installed services, and they're fully initialized as distributed systems. Notice that when Spark installed, it also installed a Spark subcommand that lets us directly interact with Spark in the data center from the same command line. Let's use the Spark subcommand to run a Spark job by typing DCOS Spark run and then the name of the Spark job. Notice how the Spark workload immediately spans out to fill the available capacity in the data center, effectively bursting into unused capacity. The Spark workload coexists with all the other workloads in my DCOS data center, giving your data center much higher utilization. Now, with all of these workloads running in my data center, what happens if a deluge of web traffic comes in? We have a traffic simulator app that we can dial up web requests to stress test our system. So let's see how it looks when we hit our data center with a lot of traffic. Let's start a traffic simulator that will send 100 network requests per second to our Ruby on Rails application. Notice how, as the number of requests per second increases, the Rails app auto-scales to accommodate the new load with no human intervention. As the traffic increases, new instances are started and automatically attached to the load balancer, all fitting within the slack capacity I already have in my data center, and it happens almost instantly. Now imagine you want to deploy a Kubernetes application. Kubernetes is a container orchestration system from Google used to build cloud-native applications, and it runs on the DCOS. With the DCOS, you can add Kubernetes to your data center the same way you add other services, by selecting it from the library, or in this example, by typing a single command, DCOS package install Kubernetes. Kubernetes is now available to run workloads, and we can instantly deploy a Kubernetes app with a single command. But in this fast-moving world, your operations team will be overwhelmed by requests for new technologies and new ways to deploy apps to support rapid development. It might be Kubernetes today, but it might also be Docker Swarm and Red Hat's OpenShift tomorrow. Again, with the DCOS, we can provide both of those services to our organization with a single command. And once these DCOS services are installed, you and your developers can deploy and scale those kinds of apps. Notice how I have 7 full-blown services now set up in my data center, all running workloads on the same cluster and all set up in under 10 minutes. All these services and applications are running on a single DCOS cluster, all sharing resources with no contention. And because we're running all of these workloads and multiplexing them across many servers, we are driving utilization through the roof. The DCOS in production typically yields 4 to 5 times more capacity than the same cluster and workloads without DCOS. Now let's see how the DCOS handles failures. We'll use a tool called Chaos to kill almost 10% of the nodes in our data center. Notice that as Chaos takes nodes out of service, all of those tasks that were running on those nodes are instantly and automatically started on other nodes in the system. This self-healing failure recovery means your operations team can sleep at night, knowing that they won't be getting 3 a.m. wake-up calls to fix machines. I hope you've enjoyed this introduction. You can find out more and even try it yourself by going to our website, mesosphere.com. You can also contact our sales team by emailing sales@mesosphere.com.
Okay, so I think you've probably seen the one or other thing there, what I've mentioned earlier in terms of trends and challenges, this attitude towards the cluster of machines you have, pets versus cattle, this utilization thing. Typically, if you look nowadays, you would have a separate cluster for your web servers and Cassandra, Spark, and so on and so forth, and they're all dimensioned essentially for peak load, which means you over-provision. You have a lot of spare capacity that you're really not using, but you're paying for that. Think in terms of TCO again. And through that multiplexing, through letting different kinds of workloads run on the same underlying machines, you really get that higher utilization. And DCOS really takes care of all these nitty-gritty details in terms of where to launch a task, where to fail over, and so on and so forth. The one last thing that I didn't explicitly mention, but Matt had it here in his demo, was this Chaos Monkey demo part where you should really not only expect but actually embrace failure in the network, in the cluster. So this is a rather good exercise. You probably don't want to do that on your production cluster every day, but being able to see how your application, especially if you have your own application there, reacts if a number of node goes away, is certainly a good thing in a QA environment. And we do that also internally. We essentially use all the tools internally as dogfooding part of the game, obviously. And having this attitude of embracing failure actually helps being able to spot errors also faster. So now, if you've seen that now and wonder, okay, where do I start? How do I get started with that? There are a number of things. I'm not going to go through that in detail. Going to share the slides right after the talk anyways. There are documentations and chat rooms on Slack or an IRC, whatever you prefer. I wanted two things I want to point out, though. These are more or less end-to-end applications. They are demo applications, so that's not something you want to deploy into production. But they're end-to-end in the sense of that you really get the idea of how to do the overall system architecture, what are the components, and you can try it out themselves. Oinka, which is I think even part of the tutorial we have included in the DCOS, so you don't even have to go there, but you can directly do it from the DCOS. Essentially a kind of Twitter clone, a Ruby on Rails web app that has Cassandra as a backend, and you can Oink, which is Oink is the new tweet. So and then you can look at how the Oinks are going. And the second part or second application is a kind of e-commerce demo, and I presented that a couple of weeks ago here in Amsterdam, and now it's available on GitHub fully. Essentially having Redis and Nginx for this end user facing part and an Elk stack for the analytics part, and essentially just using Mesos and Mesos DNS with Marathon to launch that and to wire up all these things. Okay, so that was pretty much it. As I said, first step would be go there and try it out yourself, have a look around. I wanted to have at least some 5 or 10 minutes, if that's still okay. You will tell me 5 to 10 minutes, is that still okay? Yeah. For Q&A, so whatever you have, go ahead. Yes, please.
So how do you go about troubleshooting?
Right. So currently, when you look at the community edition, you have multiple levels there. You have, if you're looking at Marathon, you will look at the Marathon logs and whatever you see there in the UI or REST interface. You have the underlying Mesos logs, and you go there, potentially having to currently, in the current version, having to SSH into the different nodes. Actually, I've seen that already internally. We're rolling out these new features that you can do that across the cluster, so that you essentially, in the same way as you can launch applications with a command line, you can essentially have access to the logs throughout. But essentially, it boils down to first level, that would be the service or whatever you have, like Marathon or whatever, where you look into how things are going, and if you can't solve it on that problem, you will then go a level deeper and use the Mesos, which the logs are pretty verbose if you want them to, so you have a pretty good idea what is going on. It certainly helps if you have a bit of a background, what Phil showed earlier on in terms of how Mesos is working. And yeah, that's pretty much it. So you essentially look at the end of the day at the Mesos logs. I've seen it myself when developing. Sometimes it's also useful if you are in a containerized environment that you are familiar with what's going on in Docker, obviously, but that really depends on what you're using there. Quite often the use case is really, I have an existing, let's say, Java application, jar or whatever, not even yet Dockerized or containerized environment, and then it would be, as soon as you can eliminate a kind of system-wide failure, whatever, you're essentially looking at the single node, and then you're using the normal debugging environments that you have there. Yes. 1, 2.
I think recently Kubernetes and Mesos announced that they were more integrating more.
Mhm.
Can you elaborate a bit on how these two tools relate and how they complement each other? Because to me it's not entirely clear.
Right. So Mesos is really this underlying kernel that looks at all the resources in the cluster, has that abstraction that it essentially says, okay, I know I have overall these and these many CPU shares and RAM and whatnot, and I'm offering that to my frameworks. Kubernetes is really, on the one hand, it comes from that insight that Google had over the years with Borg and Omega, how to do the orchestration of containers at scale. So concepts like, I don't know how familiar you are with Kubernetes, but I assume a bit since you're asking the question, things like the units being the pods and so on, that comes all from that insight they had over the years running Borg. And yeah, so we said from a product perspective, we don't want to lock in people into that one scheduler we think is the right way to do it, Marathon, which we use internally as the system, boot up and everything that Chronos or other services would be launched through Marathon. But we want to give people the freedom. So if you want to use Kubernetes as your core orchestration layer, then so be it. And in the DCOS world, you just install as you have seen and use Kubernetes, or use it together as you like. For certain setups, you probably want to use Marathon as well, so that you can really have hybrid setups. So as far as I know, there are no plans yet that Kubernetes would run anything other than containerized environments. So if you have legacy or whatever current infrastructure that you want to run and you don't want to containerize it, then Mesos is providing you that primitives that you can just run whatever you have, a shell command, a jar file, whatever. Okay. So. Okay.
Working with an overlay network that Kubernetes expects to be there, because Mesosphere is binding most of the applications onto ports onto the host, while Kubernetes actually demands of you that you have an overlay network where every pod has its own routable IP.
So the good news is I can answer one part of your question, which is the distinction between Mesosphere, and the DCOS. The bad part is I can't answer the other one right now, but I'm going to follow up with you, with our Kubernetes team. So just to clarify that, Mesosphere, that's the company, like the company I work for, right? The DCOS is the product, and Mesos is the kernel, the Apache Mesos project. To be honest, I don't know. I don't know the answer to that one. I need to check back with the Kubernetes team to come up with a sensible answer. I have a hunch, but I'm not going to say it. Yes, Mark.
Do you have recommendations for stateful services?
In what sense do you?
Well, for example, I noticed that it was automatically restarting things.
Yeah.
But if one of those was a database, that
Yes.
wouldn't work.
So there is the world before 0.23, Apache Mesos 0.23, and the world after. Up to now, and I think you might have also seen that in your process there. So up to now, 0.22 kernel of the DCOS, Apache Mesos. Mesos doesn't really have a notion of this, persistency per se. So you have to kind of out of band work around that and keep that state on your own. Now with the upcoming 0.23 version of Mesos, we're going to introduce that. This concept of persistent volumes. So you have these primitives there and you can build upon them. And I mean, to a certain extent, and I think you guys also highlighted that as well. The question is always, how much time and energy do you want to invest to, make your system a DCOS, Mesosphere, DCOS application or service? The good news is really, initially, you don't need to invest anything because you can just run it as it is directly in Marathon. Obviously, if you want to invest that, if you have that case that you want to benefit from that auto-scaling and so on and so forth, then investing in a service that then takes care of all these things makes sense. But I would, in terms of adoption, I would see that as a second step. I probably would first want to see some concrete benefit and outcome with minimal investment in terms of what I currently have, just running it in the DCOS, and then decide on I'm gonna invest in a specific framework. Yes.
So what is the solution that DCOS offers for service discovery?
So integrated is Mesos DNS, which is essentially a DNS server that runs typically on the master node and exchanges the information or polls the Mesos API, essentially asking, okay, on which IP and port is a certain task running, and exposes that in the normal DNS way. It also offers a REST API, which I use typically because if I want to use it from Python application or JavaScript or whatever, then I'm way easier to pull it out from the REST API. But as long as your application is DNS aware, it puts in that full qualified domain name and it gets out an IP address. There's no problem. I mean, you can. I've seen other people using other things as well, console or whatever. But the kind of what you get out of the box, what is shipped with the DCOS is Mesos DNS. Some more questions? 1, 2.
I'm curious, you mentioned that in version 0.23 you're going to introduce state management. Will you go, will you provide any primitives in the framework to manage the state, to move it around or to save it, or it will be like just dump it on the machine and people have to deal themselves with how they deal with it?
It is in Apache Mesos, so it's in the kernel, right? So
in the kernel.
Your framework, so where currently your framework, whatever that is, Marathon or whatever your own is, had to work around that, can now benefit from these kernel features directly.
So if you write your own scheduler or something,
Yeah.
and you want to move your application, you can say, give me the state that was running on that node, move it to this node for this application, or something similar to that.
I'm not entirely sure if that feature already is in 0.23. What you currently have is essentially, when you look at the current sandbox, it's essentially a temporary directory, right? You go there, you have something for the time running, you go away, there are no guarantees that it's still there. The first primitive, a first simple primitive is essentially you have a guarantee that when you restart, your data is still there. So you don't need to do something out of band. To the second part, I'm not entirely sure. I'm not entirely sure if in 0.23, in this first version, this support is already there. It might be still in discussion, it might be still, will it make it in 0.23 or not, but I'm not entirely sure.
This is not a technical question,
Okay.
but do you get much adoption from the hardcore sysadmin guys? Because we have sysadmin guys who hates you guys.
Mhm.
And also, if you mention the word DevOps, then it just explodes.
Okay.
It's sort of like the angry engineer.
Right.
Do you see any interest from those types of people, or is it
So
just the guys who have already bought into the DevOps?
Right. So I've been in a couple of on-site sessions where we essentially go to prospects or customers and work together and looking at the current architecture and trying to come up with a migration path. And at least I have, but maybe the sample size is too small. I have never seen anyone going like, I don't want to talk with you guys. Obviously, there is, people want to, if they want to depend on that and have their production, reliably run on that, they want to apply all the scrutiny and want to really, do all the testing. But most of the people, at least I have seen and I've talked with, are pretty open. There are concerns or worries around, what we heard already, security and other things all the way. So that's why we in the Enterprise Edition essentially really focused on this, integration, especially regarding security into existing infrastructure, because you can't, come up with a new product and then say, hey, by the way, rip out all your Active Directory, LDAP or Kerberos, whatever, because we're coming up with a new thing here. But these are the main worries that I'm aware of, that you need to be able to play nicely with whatever is there. And yeah, but I haven't seen that or heard that much. I mean, I don't run around and say like, hey, you should be a DevOps or whatever. But I do subscribe to that idea, and I think it brought a number of very good things, especially this huge gap between developers. Like, yeah, throwing it over the fence, it's not my problem anymore, right? Narrowing that gap, and it's, I think, 80% a cultural thing. It's the tooling helps, obviously, but if you just put the tooling in place and you don't have the cultural change in there, where people go like, hey, we should really work together to make that happen, then it doesn't really help a lot, right? And I think, I've seen that resistance going like, you developers, just because there is Docker, I'm not going to just run that in production. Yes, of course, there needs to be the QA part and so on. But having this shared responsibility and seeing that as one process rather than, up to here, it's my problem and then it's yours, I think that's a huge positive change. And all the worries that are there should be taken very seriously. I can't help and say, hey, that's not valid or whatever. That's based on a lot of experience and 3 a.m. wake-up calls or whatever. So you need to take that serious and essentially prove in each and every case that it makes sense and you deliver what you promised there. Otherwise, you're shown the door faster than you can say DCOS, obviously. Yeah. Any more questions?
So what's the typical number of services you see running on one node? How does Mesos deal with large numbers of small, resource offerings?
So is the question around how many tasks are running on one node, or? It's really hard to tell because you have the entire range from, you might have bare metal on-premise, you might have a virtualized environment, you might have a cloud setup or whatever. So coming up with an average number, to me, I couldn't name a number really.
So what's the optimal, what you come across?
I wouldn't. I mean, the idea is, and what I've seen so far, some sort of the minimum utilization there was always around 40-50%, and some reported up to 80-90%. To get the overall utilization, again, viewing the entire cluster there as one resource high, right? Again, this is this pets versus kettle thinking. I don't really care about a single machine as such, right? I'm more concerned about how is my cluster overall utilized. And that's the number one thing that it's also part of the Enterprise Edition, this kind of advanced scheduling, that you have a better way of controlling where you run and how you run workloads together. You get notifications and get kind of suggestions how to tweak the whole system. But it would be an interesting thing to go through that and find that out. I don't have any numbers I can tell you in terms of that's the average number. We need to dig into that to come up with a number. I don't know any by heart. Yes, please.
Is there any idea of kind of locality of hardware? So if I want to have like a framework where there's a lot of crosstalk between things, is there any way for me to achieve that, or do they just sort of get placed down?
So it depends on the framework you're using. In Marathon, for example, has that. You can essentially label things and have a lot of different ways to force or steer the way things are deployed. If you have your own framework, you also can implement something like that. But yeah, with Marathon, it's there, and in Kronos as well. If it makes sense. So the question there again is in what case do these things make sense? I mean, things like Spark, for example, is a good thing where you really want to make sure that each of the parts really benefits as much from data locality as possible. But then again, what happens if something fails? You need to somehow make sure that the data is shuffled to another one. And then coming back to your question in the back, who is taking care of that? Is that the job of the kernel, the scheduler, or the application, right? But yeah, I think there might be enough, knowledge about idle strategy in the collective minds of Google, and Google is on average 5 to 10 years ahead of time, as you can see with the things published. I would claim that these kind of optimizations, we're still in a very early stage. I think the first goal should really be, get the utilization up, that you really get something out of for the money you pay there, and then optimize things that you can, have lower latency or higher throughput or whatever. So I'm not saying it's a premature optimization, but it wouldn't probably be my first worry. There are many more things before that to get to that stage where I would really deeply worry about optimizing that part. Okay, 1, 2.
Since we're talking about locality, it seems to me that in many of the distributed solutions, locality is regarded as partially a file system problem and partially a scheduling problem. Whereas with the advancing in hardware, rec local is very often considered local enough. As far as I'm aware, Google pretty much solved this at the file system level. Their file system abstraction takes care of rec local when you're gonna get your resources within the same rec or that vicinity pretty much all of the time. What we have in open source right now is pretty much the HDFS, and that's it, right? Do you think there's going to be developments in getting that up to speed there, or maybe something else happening?
Yeah, that's a very valid question. I do think that, I mean, obviously you're right with what Google did. To what extent that is, has already trickled down into papers and white papers and open source is another question. But I mean, the number one thing to acknowledge, data has gravity, right? So it takes some time to get even a few gigabytes from that one node to the other. So at some level, you need to deal with that. You can't just assume that this happens by magic. There are things I see, I mean, I don't know if you've seen it in the demo, Kubyte being one example. New approaches to doing that. The question is at the end of the day really, to what extent do you want to have control over that, or being able to tweak that in the application layer, and to what extent do you depend on or totally trust, okay, that's something, a distributed file system or whatever taken care of for me. And I mean, I think the lesson learned from this SQL, NoSQL debate over time is also one that, if you have common tasks, it's a recurring pattern really with the DCOS. If you have common tasks, rather than reinventing the wheel over and over again, you might really want to have them in one place. Having a solid code base that has obviously over time less bugs, and you don't repeat these mistakes in the application layer. But I'm at least not aware of any concrete, new open source project I could point you to. It's like, okay, that's the way I think it goes. But it's certainly, you see these things coming up, and I would probably assume in the next year or whatever, you would see more coming down that route as well. But we're currently working also on stuff in that direction. Okay, sorry, you were next. Yeah.
I've seen that if a node goes down for, like, for example, hardware failure or anything, you can see in the overview that it's gone.
Yeah.
That tries to state that.
Yeah.
How does it do that? Does it have a constant ping? Because what happens if you, for example, experience packet loss within your whole cluster? That's
Right.
scope
Right.
with some of those.
And there are multiple levels. It doesn't always have to be that, I don't know, the hard disk drive explodes and your entire node is down, right? It could be a thing that, the distributed system, you cannot tell between, it just takes time and there's really some outage or whatever. So there are multiple levels, but essentially all these slaves have a heartbeat to the master and essentially say, hey, I'm still alive, I'm doing that and that. And by that, the master can charge, and the master is also, it's not one single master, but you can potentially have more HA so that you can fail over. So you essentially, the master is always aware of what is available, what resources are available throughout the network, and based on these reports decides, okay, can I actually launch something there, can I relaunch? And again, the Mesos kernel itself is really, I wouldn't call it dumb, but very, very focused. It doesn't make any high-level strategic decisions. It really just says, okay, here are my slaves, here are the resources, and offers that to the frameworks or services. And that's the idea of separating these concerns here, really, that the schedulers themselves, like Marathon or Elasticsearch or Cassandra or whatever, they know best what they need to do for their workload, right? They have the knowledge, okay, in Cassandra case, this is a good decision or not, or in Elasticsearch case, this is a good decision or not. And Mesos really just provides this, okay, here's what I have, and do you want to use these 5 CPU shares and 100 gigs or not, right? Yeah.
Last question.
Last question, okay.
So in the demos I've seen on the DCOS level, we tell the cloud level, whatever that is, how many nodes we want, 50, 100, 10. But as far as I understood, the cloud level can make own decisions. So an example is the AWS Elastic Beanstalk, where it would someone on this lower level decide, let's upgrade the number of nodes. Can
Right.
that work in this setup?
I'm not entirely sure if I understand your question correctly, but you were asking if you can have these decisions in terms of provisioning of the nodes in different levels, or?
Yeah, if the cloud level, like if the AWS cloud level decides, because it's Elastic Beanstalk, I'm going to increase the number of nodes, so there's more traffic.
Right.
Will DCOS then really notice that and just update how many nodes there are? Is that already?
I don't see Beanstalk and DCOS, the one operating on top of the other or whatever. These are kind of like 2 orthogonal systems. So in that sense, no. It's just, you have an assumption that, in the cloud setup, it's pretty straightforward. You can just, fire up new instances. If you're on-prem, well, you probably have some other constraints if you can fire up them that quickly. Unless you have a virtualized environment, then you probably can as well. But I would really say that's on a different level, right? It's you wouldn't run DCOS on Beanstalk or other way around.
But DCOS has similar capabilities.
Yes, the PAS level, yes, like with Marathon or whatever. Yeah. Okay, so that was the last question.
That was last question.
Thank you.